Hello guys, welcome. In today's video we are going to discuss exercise number 1.2. In previous video we have discussed Euclid division lemma. After that we have discussed some questions from exercise 1.1, and in today's videos we are going to discuss from exercise 1.2. Do not expect me to do all the questions. I'm going to do only the important questions, and I'm going to explain you the concept behind it. Okay, what are the things you need to understand to do that question. Okay, the number may be changed, but these are the questions which is asked frequently in board exam. Okay, so listen very carefully. So let's begin. Chapter number 1, number system, exercise number 1.2. Okay, let's see. First, let us understand the concept of LCM and HCF. More importantly than HCF, LCM is more important in exam point of view, and in chapter point of view. In exercise 1.2 you are going to know both of these. Okay, this is disturbing me all the time. Let me just remove this one. Okay, now LCM and HCF. Okay, let's see what is LCM. You know LCM, right? LCM, least common multiple, right? Least common multiple. Take any two number. Okay, the number may be 12 and 16. Okay, now we are going to write the multiple of 12 and 16, and we are going to find out which is the common to both of these, and that should be the least. Suppose let's say take 12 and 16, and you are going to do prime factorizations. 2 6 is 12, 2 8 is 16, 2 3 is 6, 2 4 is 8, 3 4 is 12, 12 2 is 24, 24 2 is 48, right? You know how to find out all these things, right? You know how to find out the LCM. Let me explain what is 48 here. Now if you happen to write the multiple of 12, 12 1 is 12, right? 12 2 is 24, 12 3 is 36, 12 4 is 48. Same thing you write with 16, 16 1 is 16, 16 2 is 32, right? 16 3 is 48. Now we are writing the multiple of 14, 12 and 16. Let me separate this one, you may get confused here. We are writing the multiple of 12 and 16, and you can see here in the multiple of 12 and 16 the common one, okay, and the least common one, that is 48 to both of these. So that is the LCM, right? We find out the LCM here. What is the meaning of LCM? It should be the multiple of both the number, and that should be the least one. Okay, that is LCM. Now what is HCF? Take any number. Suppose let's take same two number 12 and 16. Now we are going to divide 12 and 16 by small number. So factors are 12. Factors on 12 will be, you are going to find the canonical decomposition. If you happen to know the canonical decomposition, it will be like this. Okay, this is canonical decomposition. You can find that canonical decomposition in exercise number 1.2, question number 1. Okay, you can do this way. I'm not going to do any questions, but let's find the canonical decompositions of 12. 2 6 12, 2 3 is 6. So we can write this as 2 into 2 into 3, right? Now you write again for 16. 16 also you can write as 16. 2 8 is 16, 2 4 is 8, 2 2 is 4. We can write 16 as 2 into 2 into 2 into 2. So what is the common number, that is what is the common, smallest common number to both this number? Take 1, 2 is common to both, another 2 is common, and another 2 is common. Okay, now nothing more is common here. So you find the HCF. HCF will be, I'm sorry, I think this should be 3. Okay, so common is 2 and 2, only 2 are common, only 2 are common, so 2 to the 4. So HCF is 4. What is HCF? The least common factor, the number we are going to divide that number by a particular number, and that should divide both the number. Okay, here 4 can divide to both 12 and 16. Okay, 4 3 is 12, 4 4 is 16. We can divide by 4 to both this number, and that 4 should be the highest among which we can divide both the number. We cannot divide by 6, we cannot divide by 8 to both the number. We can divide by 6 to 12, but we cannot divide 6 to 16. And same thing with 8. We can divide 8 to 16, but we cannot divide 12 by 8. Okay, so 4 is the highest number that we can divide both this number. So you can understand the concept of HCF and LCM. I didn't think so I'm too fast, because this is the basic you need to know, LCM. So now let's understand, let's do the question. I think you are well equipped to do the question. Let's see, question number 1. This is very important question. It is asked in exam. Okay, I think it must be question number 8 or 9 in your exercise. Okay, so find a least number which when divided by 24, 36 and 60 will leave in each case the remainder 7. Now look here, the question is saying that remainder should be 7. Okay, and the number must be the number which leaves the remainder 7 must be divided by this one. So now first let's understand the concept of remainder 0. So what will be the number which when divided by 24, 36 and 60 the remainder will be 0? Let us understand that number first. Okay, so what if the remainder is 0? That means we can divide that number. So let's say let's take any number. Suppose let's say x, and we are going to divide by 24, 36 and 60. We are going to divide by 24, 36 and 60, and the remainder should be 0. First let's find that number. So what will be that number? That number for leaving remainder 0, that should be the LCM of these three numbers, right? So let me find the LCM first. So what you are going to do this in this question first? We are going to find the LCM. Okay, let's find the LCM now. Let me change the pen and let's find the LCM. LCM of solution, LCM of 24, 36 and 60 will be, what will be the LCM? Let's find the LCM this side. Okay, you know how to find the LCM, right? I hope you know. Okay, it's not that tough even. 36 and 60. So 24, 202, 2 to the 4, 202, 2 8 the 16, 2 3 the 6, 30. I'm just doing, okay, I know that I can write that again also, but I'm just doing for you. Okay, so listen very carefully. 2 6 the 12, 2 9 the 18, 2 15 the 30, right? What this is disturbing me. Same thing. Now you divide by 3, 3 to the 6, 3 3 the 9, 3 5 the 51. Multiply all this number. All these are prime number. Okay. Now you can divide 2 to the 4, 4 to the 12, 12 to the 24, 24 5 the 24 5 the 120, right? 123 the 360, right? The LCM will be 3. The LCM will be, look here, it will be 360. This is the LCM. Okay. Now we have written the LCM. Now when we divide 360, if we happen to divide 360, let me get the eraser and let me, you find out the LCM. So let me remove all these things. Okay, now if you divide, suppose let's say if you happen to divide 24 into 360, 24 1 is 24, right? 12, 120, 24 5 is 120. Where is it gone? When you happen to divide 24, 360, 24 1 is 24, 12, 120, 12 6 is 12 5 is. It is disturbing me a lot. Okay, now we have got the LCM as 360. Okay, the LCM is 360. It is not clear here. Okay, now if you divide 360 by 24, remainder will be 0. If you divide by 36, remainder will be 0. If you divide by 60, it will be remainder will be 0. You just check it out. Okay, now for remainder to be 7, what we can do? We can write 360 is the LCM plus 7 equal to 367. So the answer is 367. You check it out. You divide this 367 by 24, you divide by 36 and you divide by 60, whether the remainder will be 7 or not. I'll do one for you. Let me divide by 36 into 367. I'll do this for you. Remaining you are going to do. Okay, 36 1 ja 36 360 36. What the hell is happening this one? We got 360 and for the answer will be 360 plus 7, 367. So we are checking 367 divided by 360. divided by 60. Okay, sorry, divided by 36. Let's check it about 36. Let's check by 36. 36 on the 36. 7 will come down here. It will be 0. Remainder is 7, right? You are going to check by 60 and 24. Let us do the another question. I hope you understand this question. Okay, I'm not doing how to write in exam. You just check it out for your teacher. I'm just explaining you how to do the question. It is very important in exam point of view. Okay, let us do another one. Now let us do question number 2. Find the least multiple of 11 which when divided by 6, 7 and 10 leaves the remainder 4 in each case. Here we are going to do another question which is little bit similar, and we need to do something extra in this. Okay, here we are going to divide 6, 7 and 10. One particular number is there. Let's take any number x, and if we happen to divide by 6, 7 and 10, the remainder will be 4. Okay, now for that we need to do like before. Like before, find the LCM. Okay, it's simple as it is. It's simple. It is quite simple. Find the LCM of these three numbers. So LCM of these three numbers will be solution LCM of 6, 7, 10 will be, what will be the LCM? You find out the LCM. LCM will be, you know how to find the LCM, right? 6, 7, 10. Divide by 2. 2 is the first prime number which you are going to divide. 2 3 is 6, 7 2 5 is 10. All these are prime numbers. 7 5 is 35 with the 70, 73 is 210, right? We can write 210 as LCM. Now another thing, that this 210, the answer must be divided by 11. Okay, so can 210 be divided by 11? We have to check it out and we have to write it down. 210 when divided by 11. 11 was the 11, right? 10 is the remainder 100. 11 9 is 99. Remainder is 1, is it? We can write 210 as 11 into 19 plus 1. Is it okay? We can write, is it? Now what is the another concept that we are going to consider here? The number, okay, which is the multiple of 11. We can understand that. Okay, it must be divided by 6, 7 and 10. Okay, we can understand the remainder will be 4. We understood that. Now for the remainder to be 4, 210 will be 210 plus 4. Okay, you can understand. 210 we can write into 11 into 9, 19 plus 1 by Euclid division lemma. We know how to do all these things. Okay, now 210 plus 4. Now that number must be multiple of 210. Okay, for that to be least multiple of 11, so we have to multiply 210 by a particular number. Suppose let's say k. Okay, we can write 210 as 11 into 19 plus 1 k plus 4. We are writing 210 as this one from here. Okay, now let us understand once more. Let's see what is the possible number. So let's make it little bit convenient. 11 into 19k plus 4. You understood, right? I multiplied by k to this and k to this, and okay, now 11 into 19k, we can take this as one number plus k plus 4 as another number. Now the condition, this is our answer. If we happen to divide 6, 7 and 10, the remainder will be 4 in all this case. This 11 into 19k plus 4, all this number. If we happen to divide by 6, 7 and 10, remainder will be 4. But whether it is multiple of 11, we have to check it out. For that, this number must be multiple of 11. Make this number multiple of 11. Can this number be divided by 11 or not? This particular number, we can divide by 11, right? 11 is 11, so we can divide. This is multiple of 11. Can k plus 4 is it a multiple of 11? If you happen to write k equal to 1, 4 plus 1, 5. Can we divide 5 by 11? No, is it? 2, 4 plus 2, 6. Same thing. Check it out. Which number must be check it out. Make this number such that it must be divided by 11. So put the value of k such that this is divided by 11. The number, suppose let's say put k is equal to 6. 6 plus 4, 10. Can 10 be divided by 11 or not? No, right? So put k is equal to 7. That 7 plus 4 is 7 plus 4 is 11, right? 11 is divided by 11. Yes. So the value of k we have found out by inspection, right? We don't know how to find, like not by formula. Okay, we have found out by inspection, by checking out. Okay, so the k value will be 11. K value will be 7. Okay, so what will be the answer? You put, instead of k, you put 7 here. So 210 into 7 plus 4. Is it visible to you? I don't think so. 7 1 is 7, 7 2 is 14, 7 2 is 14, 7 1 is 7, 1 7 4 0 7 0 plus 4. So if you have it, the plus 1 4 7 4, this is the answer. Check it out. This number, is it multiple of 11? Yes, it is multiple of 11. You divide by 6, 7 and 10 and check it out whether the remainder will be 4 or not. So thank you so much. That's all from chapter number 2. Chapter number 1, the exercise number 1.2. Most of the question asks are this. I'm not going to do all the questions. In coming days, when I'm taking a full course, that time I'm going to do everything, but not now. Okay, now these are the now I'm doing only the important question. So thank you so much. We'll meet in the next video. Thank you once again.